What is punching shear and structural failure? Have you ever wondered what happens when a heavy load is placed on a concrete slab? One of the possible outcomes is a phenomenon known as punching shear. This type of mechanical failure can occur in structural elements like reinforced concrete slabs and foundations. It typically happens when a concentrated load, such as the weight from a column, is applied to a flat slab. When this load is applied, it creates localized shear stresses around the point of contact. If these stresses exceed the slab's shear capacity, a sudden and brittle rupture can occur. This leads to what we call punching shear failure. In this scenario, the slab cracks and separates around the loaded area, often forming a conical or pyramidal fracture surface. It can look as if the column has punched through the slab. This type of failure is particularly concerning because it can happen without much warning. The consequences can be severe, including structural collapse and risks to human safety. Punching shear is most commonly seen in flat slabs and foundations like pad footings, pile caps, and raft foundations. These structures are designed to handle concentrated loads, but if not properly analyzed, they can fail dramatically. The mechanics behind punching shear involve the concentration of shear stresses on a perimeter around the loaded area, known as the critical shear perimeter. When the applied shear first divided by the product of this perimeter length and the slab's effective depth exceeds the allowable shear stress, the slab is at risk of failure. Unlike bending failure, which is governed by flexural stresses, punching shear is all about shear stresses. The main reinforcement designed for bending does not help in this case. To prevent punching shear, engineers must analyze and design slabs carefully. They need to consider factors like slab thickness, reinforcement detailing, and the magnitude of the load. Common strategies include using shear reinforcement or increasing the slab depth to enlarge the critical perimeter. This helps improve resistance to punching shear. Ignoring the potential for punching shear can lead to sudden failures around columns or concentrated loads. This is why it is essential to consider this failure mode in the design process. Understanding punching shear helps clarify why some structural failures occur unexpectedly and how localized stresses can lead to mechanical breakdowns. It emphasizes the need for detailed analysis and proper reinforcement to maintain structural integrity and safety.